Picture this. You're standing at the edge of a massive glacier. The ice stretches as far as you can see in every direction, a frozen wasteland that's held North America in its grip for thousands upon thousands of years. But something's changing. The ice is retreating. This is 10,000 years before Christ, and as that ice pulls back like a slow-motion curtain, it reveals something extraordinary. Mountains. Towering, jagged peaks that scrape the sky. The Rocky Mountains, the Appalachians, ranges that dwarf anything most humans have ever seen. Now here's the thing that gets me about this moment in history. The first people to see these mountains really see them as the ice retreated. They didn't have Google Earth. They didn't have topographical maps or weather reports or any of the tools we take for granted today. They had stone tools, animal skins, and whatever knowledge they could carry in their heads. And they looked at these peaks and made a decision that would echo through the next 12,000 years of human history. They decided to go up. Think about that choice for a second. These weren't recreational hikers with GPS units and emergency beacons. These were people for whom every decision was literally life or death. Winter was coming. Winter was always coming in those days. And they had to find shelter. They had to find food. They had to survive. But mountains? Mountains don't make survival easy. Mountains make survival brutal. See, the first humans to venture into these peaks learned something that mountain people have known ever since. Mountains demand tribute. Not gold or silver. Mountains demand respect. Respect paid in blood, sweat, and ingenuity. Because mountains will kill you if you don't understand their rules. And what are those rules? Well, the first mountain dwellers figured them out the hard way. Rule number 1. Thermal mass stores warmth. If you can heat up stone during the day, it'll give that heat back to you at night. But here's the catch. You have to understand which stones hold heat and which ones don't. You have to know how to position them, how to use them. Get it wrong, and you freeze to death. Rule number 2. Wind kills faster than cold. You might think the biggest threat in mountains is freezing temperatures. Wrong. It's wind. Wind strips heat from your body faster than you can generate it. Wind turns a survivable cold night into a death sentence. So the smart mountain people, they learn to hide from the wind. Rule number 3. Shelter placement determines life or death. Build in the wrong spot and you wake up buried under an avalanche. Or you wake up to find your shelter has been torn apart by winds you didn't even know were coming. The mountains teach this lesson exactly once. These early mountain people, they didn't have the luxury of learning these lessons from books. They learned them by watching their friends and family die, by making mistakes that cost everything, by slowly, painfully, developing techniques that worked. And here's where the story gets really fascinating, because we're not just talking about one group of people in one mountain range. We're talking about humans across the world, facing the same challenges, developing similar solutions without any contact with each other. Take the Cherokee. Now, by the time European explorers like Daniel Boone encountered Cherokee mountain settlements in the 1700s, these people had been perfecting mountain architecture for thousands of years. Thousands. The Cherokee developed something that still amazes modern engineers: sophisticated log construction using fire. They would take a fallen tree, and we're talking about trees that were 3, 4, 5 feet in diameter, and they would use controlled fire to hollow out precise sections, not random burning. Controlled fire. They could create joints and notches and connections that fit together like puzzle pieces. But it gets better. These weren't just log cabins like you see in tourist areas today. Cherokee winter lodges were architectural marvels designed for one purpose: keeping people alive when the mountains tried to kill them. They built these lodges into hillsides. Think about that engineering choice for a moment. By digging into the hill, They automatically protected themselves from wind. The earth around them provided thermal mass, air. It stored heat during warmer periods and released it slowly. The hillside itself became part of their heating system. Then they covered the whole structure with earth. More thermal mass, more insulation. These buildings didn't look like much from the outside. They looked like small hills with smoke coming out of them. But inside, families stayed warm through blizzards that would have killed anyone caught in the open. And the foundations. Cherokee builders used stone foundations that distributed weight perfectly. No settling, no shifting. Some of these foundations are still there today, after centuries of mountain weather, still level, still solid. When Daniel Boone first encountered these structures, he found architectural wisdom that had been perfected over millennia. These weren't primitive shelters. These were sophisticated engineering solutions that modern builders still study and copy. But here's what really gets me excited about this period. The same innovations were happening on the other side of the world. Across the Atlantic, in the Swiss Alps and Bavarian peaks, completely different groups of people were facing the exact same challenges and developing remarkably similar solutions. Think about this. Viking longships brought Nordic building techniques south through European river systems. Vikings weren't just raiders, they were traders, explorers, and yes, builders. They understood timber construction in ways that would make modern carpenters weep with envy. These Nordic techniques merged with Roman stonemasonry. Now that's a combination that should get your attention. Roman engineering. We're talking about the people who built the Pantheon, who created aqueducts that still work today, combined with Viking timber craftsmanship that could build ships capable of crossing oceans. The result? By 1000 after Christ, Swiss chalets stood in the Alps like wooden castles. But here's the brilliant part. They weren't rigid like stone castles. They were engineered to flex with mountain winds rather than break. Modern structural engineers call this dynamic loading response. The Swiss mountain builders called it not getting your roof torn off in a storm. These chalets used massive timber frames. We're talking about support beams that were 2 feet thick, 3 feet thick. Trees that had grown for hundreds of years became the bones of buildings designed to last hundreds more. The joints were cut so precisely that no nails were needed. Each beam locked with its neighbors in what builders called an unbreakable bond. And they were right. Some of these buildings are still standing today, still occupied, still keeping families warm through alpine winters that would challenge modern heating systems. But here's what I find most remarkable about this early period of mountain building. It wasn't just about survival. These structures represented something deeper. Mountains demand a different relationship between humans and their environment. In lowlands, you can dominate the landscape. You can clear forests, divert rivers, level hills. But mountains? Mountains don't allow domination. Mountains demand cooperation. The successful mountain builders, Cherokee in the Appalachians or Swiss in the Alps, they understood this. Their buildings weren't impositions on the landscape. They were negotiations with it. Think about a Cherokee winter lodge built into a hillside. The building and the hill become one structure. The earth provides thermal mass. The slope provides wind protection. The builders work with natural features instead of fighting them. Or consider those Swiss chalets designed to flex with mountain winds. Modern buildings try to resist forces. They're designed to be rigid, immovable. But mountain winds aren't interested in your engineering ego. Mountain winds will find the weakness in rigid structures and exploit it ruthlessly. So the smart mountain builders created structures that bent without breaking, that moved with the forces trying to destroy them, that survived by adapting rather than resisting. This is mountain wisdom, and by 1000 after Christ, this wisdom was spreading. Alpine trade routes created the first mountain boom towns. Merchants traveling through passes like the Sankt Gotthard needed secure lodging. They needed buildings that could be constructed quickly, efficiently, in locations where every piece of material had to be carried up treacherous mountain paths. The inn at St. Gothard Pass was rebuilt repeatedly after avalanches. But here's the genius part. The builders developed a system where structures could be quickly reconstructed from prefabricated components. Think about that. Prefabricated construction. In 1000 after Christ, they created buildings designed to be destroyed and rebuilt. Because sometimes the mountain wins. Sometimes the avalanche takes everything. But if you design for that reality, if you plan for destruction, you can rebuild faster than anyone who pretends disaster won't happen. This is where mountain architecture becomes philosophy. It's not just about keeping rain off your head. It's about understanding your place in a larger system. It's about building with humility. Because mountains have been here for millions of years, your building is a temporary visitor. The mountain will still be here long after your great-great-grandchildren are dust. So you'd better build with respect. But respect doesn't mean surrender. It means understanding. It means working with forces instead of against them. It means learning lessons that can only be taught by wind and ice and the constant threat of sudden death. And those lessons, those hard-won insights about thermal mass and wind protection and foundation placement and structural flexibility, they were about to travel across an ocean to a continent where the mountains were bigger, wilder, and more dangerous than anything European builders had ever imagined. The stage was set for the next chapter of mountain architecture. European knowledge was about to meet American wilderness. Traditional techniques were about to face challenges that would test every assumption, break every rule, and demand innovations that would change mountain building forever. Because in 1804, Lewis and Clark were going to return from the Western Territories with tales of mountain ranges that dwarfed the Alps, and the race for the American West was about to begin. Now, let's jump forward to the 12th century, and I want you to picture something that sounds almost impossible today. Imagine a world where the secrets of building, really building, the kind of construction that lasts centuries, those secrets are guarded like state intelligence, where master craftsmen form guilds that operate more like military organizations than trade associations, where knowing how to cut a perfect timber joint could mean the difference between prosperity and poverty, and between respect and exile. This was medieval Europe. And in the mountains of Austria, Switzerland, and Bavaria, something extraordinary was happening. The 12th century witnessed the rise of legendary mountain builders whose names echo through architectural history. And when I say legendary, I mean these guys achieved things that modern architects study and still can't fully replicate. Take Master Wilhelm von Zillertal. Now, this is a name that should be carved in granite somewhere, because Wilhelm perfected something that seems impossible until you see it with your own eyes. He developed the technique of interlocking log construction that required no nails. Zero. Not one piece of metal hardware. Think about that for a second. You're building a structure that needs to withstand alpine winters, winds that can knock down trees, snow loads that would crush a modern house, temperature swings that make metal expand and contract until it fails, and you're doing it without a single nail. Wilhelm's technique was this. Each timber was precisely cut to lock with its neighbors, not just fit together, lock together, like a three-dimensional puzzle where every piece supports every other piece. The joints were so tight that when the wood swelled with moisture, the building actually got stronger. His apprentices carried these secrets across European mountains, creating a guild system that guarded construction knowledge like military secrets. And here's the thing, they had good reason to be secretive, because buildings that could survive in mountains, those buildings were literally the difference between life and death for entire communities. But Wilhelm wasn't working in isolation. Across the mountains of Norway, another master builder was pushing the boundaries of what was possible with wood and stone. Master builder Olav Haraldsson developed something that still makes structural engineers shake their heads in amazement. He figured out how to set massive timber posts on stone foundations in a way that could withstand both earthquake and hurricane. Now here's where it gets really interesting. Norway gets earthquakes. Not often, but they happen. And when an earthquake hits a rigid structure, that structure breaks. But Olav's buildings? They rode out earthquakes like ships riding out storms. The church at Borgund, completed in 1190, demonstrated engineering so advanced that modern architects still marvel at its mathematical precision. This building uses principles of structural dynamics that weren't formally understood by engineers until the 20th century. But Olav understood them intuitively, through trial and error and careful observation of what worked and what didn't. The building rises like a wooden spear thrust toward heaven. Multiple levels, each one smaller than the one below, creating a structure that's incredibly stable while using minimal materials. The weight distribution is perfect, the wind resistance is perfect, the snow load capacity is perfect, and it's still standing. Over 800 years later, it's still standing. But here's what gets me most excited about this period. These master builders weren't just solving engineering problems. They were creating a new form of competition between regional powers. German mountain lodges became showcases of regional power. Competing nobles commissioned ever more elaborate hunting retreats, not just for comfort, but to demonstrate their dominance over the mountain realm itself. The Lodge of Hohenschwangau, built for Bavarian King Maximilian in 1832, featured heated stone floors and timber walls 3 feet thick. 3 feet. That's not a wall, that's a fortress. These weren't merely buildings, they were statements carved in wood and stone. But here's the brilliant part. These competitions between nobles drove innovation faster than anything we see today. Each lodge had to outdo the previous one, not just in luxury, but in engineering achievement. Builders were pushed to solve problems that had never been solved before. How do you heat a massive stone structure in the middle of winter? How do you create windows large enough to enjoy mountain views without compromising structural integrity? How do you transport materials to locations that can only be reached on foot or by pack animal? The solutions these builders developed changed mountain architecture forever. They created underfloor heating systems using hot water carried through stone channels. They developed window designs that used multiple layers of protection, shutters, frames, and early forms of insulation. They pioneered modular construction techniques that allowed complex structures to be assembled from components small enough to carry up mountain trails. And then, trade routes changed everything. Alpine passes became highways for medieval commerce. Merchants traveling between Italian city-states and northern European markets needed secure lodging. But not just any lodging. They needed buildings that could be trusted with valuable cargo, that could protect travelers from both weather and bandits. This created the first mountain boom towns, and with them, the first mass market for mountain construction techniques. The inn at Sankt Gotthard Pass became a testing ground for innovations that would spread across Europe. This building was rebuilt repeatedly after avalanches, but each reconstruction incorporated lessons learned from the previous destruction. Here's what's brilliant about this. The builders developed a system where structures could be quickly reconstructed from prefabricated components. But not just any prefabrication, ISE, intelligent prefabrication that accounted for the specific challenges of mountain construction. They created standardized joints that could be cut in valleys and assembled on peaks. They developed modular wall systems that could be adapted to different foundation conditions. They pioneered inventory management systems that ensured replacement parts were always available. Think about this. We're talking about supply chain management in 1200 after Christ, in the middle of the Alps, where every piece of material had to be carried by hand or pack animal. These weren't primitive builders working with crude tools. These were sophisticated engineers solving complex logistical problems with solutions that wouldn't be out of place in a modern construction manual. But here's where the story takes a turn that still gives me chills. All of this knowledge, all of these techniques and innovations and hard-won insights, they were about to meet something completely new. European mountain wisdom, perfected over centuries, was about to encounter mountain ranges that made the Alps look like foothills. Because across the Atlantic, Lewis and Clark were mapping territories that contained mountain peaks higher than anything Europeans had ever imagined. Ranges that stretched for thousands of miles. Weather systems that made alpine storms look gentle. And the people who would tackle these new mountains? They wouldn't be guild-trained master craftsmen with generations of accumulated knowledge. They would be pioneers, mountain men, settlers who had to figure everything out from scratch in conditions that would kill you if you made the wrong choice. The stage was set for a collision between old-world knowledge and new-world challenges that would create an entirely new form of mountain architecture. European techniques were about to be tested, modified, and revolutionized by the demands of the American wilderness. The next chapter of mountain building was about to begin, and it would be written in the blood, sweat, and desperate ingenuity of people who looked at the Rocky Mountains and decided to make them home. 1804 changed everything. Lewis and Clark returned from their western expedition with tales that seemed impossible to believe. Mountain ranges that dwarfed the Alps, peaks that scraped the sky for thousands of miles, rivers that carved canyons deep enough to swallow entire European cities, and gold that glittered in every stream, waiting for anyone brave enough to go get it. The race for the American West began, and mountain cabins became the advance posts of empire. But here's the thing that gets me about this moment in history. The people heading into these mountains weren't master craftsmen with centuries of accumulated knowledge. They weren't guild-trained builders with specialized tools and time-tested techniques. They were mountain men, trappers, pioneers, people who looked at mountain ranges that could kill them in a dozen different ways and said, "Yeah, I'll make that work." And somehow, they did. Take Hugh Glass. Now, if you know anything about American frontier history, you know Hugh Glass as the guy who got mauled by a grizzly bear and crawled 200 miles to safety. But here's what most people don't know. After that bear attack in 1823, Glass built his recovery cabin using techniques that would become the template for American mountain architecture. Think about this situation for a second. You're Hugh Glass. You've just survived an encounter that should have killed you. You're injured, alone, hundreds of miles from the nearest settlement. Winter is coming, and winter in the Rocky Mountains doesn't negotiate. What do? You build. You build or you die. Glass's recovery cabin used techniques that blended European knowledge with Cherokee wisdom. But here's the brilliant part. He adapted both traditions to solve problems that neither had faced before. His design, logs chinked with moss and clay, roof angled to shed snow but not so steep that wind could grab it and tear it off. Foundation raised on stones to prevent rot, refloss, because in mountain conditions, rot kills buildings faster than fire. This became the template copied by thousands of settlers, not because Glass published architectural plans, but because his cabin worked. It kept him alive through a winter that would have killed lesser builders. But Glass was working at relatively low altitude. The real challenge came when pioneers like Jedediah Smith pushed into the Sierra Nevada, where altitude and weather extremes demanded completely new solutions. At 10,000 feet, traditional log construction failed. The air is thinner, temperature swings are extreme, we're talking about 80-degree differences between day and night. Timber splits, joints fail. Everything you think you know about building stops working. Smith discovered this the hard way. His first high-altitude cabins were disasters. Walls cracked, roofs collapsed, Buildings that would have been fine at lower elevations became death traps above timberline. So, Smith innovated. He developed double-wall construction with insulating air gaps. Think about that. This is a technique that wouldn't be invented by architects until the 1900s. But Smith figured it out in 1820s because his life depended on it. The inner wall provided structural support. The outer wall protected against weather. The air gap between them created insulation that prevented heat loss while allowing the structure to flex with temperature changes. Modern builders call this thermal bridging prevention. Smith called it not freezing to death. But the real game changer came in 1849. The California Gold Rush created the first mass market for mountain shelters. Picture this. In a single year, over 300,000 fortune seekers poured into the Sierra Nevada. 300,000 people who needed shelter, who needed it fast, and who didn't have time to learn mountain building techniques through trial and error. Entrepreneurs like John Sutter saw opportunity. Sutter made his fortune not from gold, but from selling pre-cut cabin kits to miners. These kits were shipped around Cape Horn from Maine, a journey of thousands of miles, and designed to be assembled in 3 days without specialized tools. Think about the engineering challenge this represents. You're designing a building kit that needs to survive months at sea, then be carried up mountain trails by pack animal, then be assembled by people who've never built anything more complex than a campfire. The kit had to be foolproof. Every piece had to fit exactly. Every joint had to be simple enough for amateurs to execute correctly. And the finished building had to withstand Sierra Nevada conditions that destroyed structures built by experienced craftsmen. Sutter's kits worked because they incorporated lessons learned by mountain men like Glass and Smith. Pre-cut logs with standardized chinking grooves, roof components designed for optimal snow shedding angles, foundation systems that worked with irregular mountain terrain. But here's where the story gets really interesting. Because while individual mountain men were solving construction problems through desperate innovation, organized groups were developing entirely different approaches. Mormon pioneers under Brigham Young faced the challenge of settling the Wasatch Mountains. But Mormons had something most mountain settlers didn't have: community organization and coordinated labor. Their communal cabin-raising techniques, perfected in 1847, could erect a complete log structure in a single day, using coordinated teams of 50 men. 50 men who had practiced these techniques, who understood their roles, who could work together like a construction machine. But it gets better. The Mormons pioneered the use of local materials in ways that revolutionized mountain construction. They discovered that certain Utah clays made superior chinking that hardened like concrete. Not just adequate chinking, superior chinking that lasted longer and insulated better than anything used in European construction. They developed techniques for using local stone that maximized thermal mass while minimizing construction time. They created building designs that could be adapted to different mountain microclimates without losing structural integrity. And here's what really gets me excited about this period. These weren't isolated innovations. Knowledge was spreading faster than ever before in human history. Mountain men shared techniques at annual rendezvous gatherings. Mormon settlers published building guides for new converts heading west. Gold miners wrote letters home, describing construction techniques that worked in Sierra Nevada conditions. For the first time, mountain building knowledge was being systematically collected, tested, and distributed. Traditional techniques that had taken centuries to develop in European mountains were being adapted and improved in decades in American conditions. But the American mountains weren't just bigger than European ranges. They were different in ways that demanded completely new approaches to construction. European mountains had been inhabited for thousands of years. Infrastructure existed. Supply chains were established. Traditional materials were available. American mountains were wilderness. Every nail had to be carried hundreds of miles. Every piece of glass represented a minor miracle of logistics. Builders had to work with whatever materials they could find locally or do without. This created a culture of innovation that's hard to imagine today. When you can't buy what you need, you make what you need. When traditional techniques don't work, you invent new ones. When your life depends on your building skills, you get creative fast. Mountain men developed techniques for using green timber when seasoned lumber wasn't available. They created joinery methods that worked with irregular logs cut by axe rather than sawmill. They pioneered foundation systems that worked with mountain bedrock, shifting soil, and seasonal frost. They learned to read mountain weather patterns and adjust construction schedules accordingly. They developed tool modification techniques that made standard equipment work in mountain conditions. They created maintenance procedures that kept buildings functional through seasons that would destroy lowland structures. But here's what I find most remarkable about this period. These innovations weren't just about survival. They were creating a distinctly American approach to mountain architecture. European mountain building was about permanence. Structures designed to last centuries, built by craftsmen with lifelong specializations, using techniques refined over generations. American mountain building was about adaptability. Structures that could be built quickly by generalists, modified as conditions changed, rebuilt when necessary. Buildings that solved immediate problems rather than making grand statements about human dominance over nature. This wasn't better or worse than European approaches. It was different. It was a response to different conditions, different resources, different social structures, and it was about to face its greatest test. Because railroad barons and timber kings were looking at the American West and seeing opportunity on a scale that would dwarf anything previously attempted, the age of mountain palaces was about to begin. European craftsmanship was going to meet American scale and ambition. Traditional techniques were going to be pushed to their absolute limits by people with unlimited budgets and impossible dreams. The stage was set for the golden age of American mountain architecture. An age when humans would build structures in the mountains that seemed to defy gravity itself. When log cabins would become wooden cathedrals. When the American wilderness would be conquered by the most audacious building projects in human history. The 1870s marked something unprecedented in human history. For the first time ever, people were building in mountains not because they had to, but because they wanted to. Not for survival, but for luxury. Not to escape civilization, but to bring civilization to the wilderness. Railroad barons like Leland, Stanford, and timber kings like Frederick Weyerhaeuser commissioned mountain palaces that defied gravity itself. These weren't cabins. These weren't even houses. These were wooden cathedrals that proclaimed humanity's conquest of the vertical realm. And they were absolutely magnificent. The Adirondack Great Camps represented the pinnacle of rustic luxury. William Durant's Camp Pine Knot, completed in 1877, featured 67 rooms connected by covered walkways. 67 rooms in the middle of the wilderness. Each building used trees so massive that single logs formed entire walls. Picture this. You're standing in the dining hall at Camp Pine Knot. The ceiling soars 40 feet above your head, supported by whole trees used as columns, not beams cut from trees, whole trees. Trees that had grown for centuries became the bones of buildings designed to last centuries more. But here's what gets me most excited about this period. The engineering challenges these builders faced were absolutely staggering, and they solved them using nothing but human ingenuity, traditional materials and brute force logistics that would make modern project managers weep. Railroad access revolutionized everything. The Central Pacific's completion through the Sierra Nevada in 1869 brought steel hardware, plate glass, and even grand pianos to previously inaccessible peaks. Think about that. Grand pianos. Carried by rail and pack animal to mountain locations where a single mistake could mean death. The Southern Pacific's Shasta route opened California's Cascade Mountains to development, spawning elaborate hunting lodges and retreat centers that represented the absolute peak of mountain construction techniques. But the real marvels emerged from this railroad boom, engineering projects that pushed the boundaries of what was possible with wood, stone, and 19th century technology. The Mount Washington Hotel in New Hampshire, built in 1902, required 250 rooms to be heated by a central steam plant connected by miles of underground pipes. Miles of underground pipes. In mountain bedrock, using steam technology that had to work reliably in conditions that would destroy urban systems, the structure's foundation required blasting directly into granite. Not digging, blasting. They used dynamite to create level building platforms on mountainsides that had never been modified by human activity. And the timber frame? Douglas fir logs shipped 3,000 miles from Oregon. 3,000 miles. Each log selected for specific structural properties, transported by rail across an entire continent, then assembled using joinery techniques that required absolute precision. But even the Mount Washington Hotel pales compared to what happened in Yellowstone. Old Faithful Inn, completed in 1904, became the world's largest log structure. Think about that designation for a moment. The world's largest log structure, not the largest in America, not the largest of its time, the largest ever built by human beings. Architect Robert Reamer designed a building that seemed to grow from the forest floor. The lobby's ceiling reached 76 feet. 76 feet. Supported by massive Douglas fir columns that retained their bark, creating the illusion that living trees were holding up the roof. The construction logistics were absolutely insane. The structure required over 500 railroad cars of timber. 500 railroad cars. Each car carrying logs that had been selected from specific forests, cut to precise specifications, shipped thousands of miles, then assembled using techniques that had never been attempted on this scale. The project took 3 years to complete. 3 years of coordinated effort by hundreds of skilled craftsmen working in conditions that would challenge modern construction teams. No power tools, no hydraulic equipment, no computer-assisted design, just human skill, traditional techniques, and an absolute refusal to accept that anything was impossible. But here's what really gets me about Old Faithful Inn. It wasn't just an engineering marvel. It was a philosophical statement about humanity's relationship with the natural world. Reamer could have built a conventional hotel. He could have used modern materials and standardized techniques. Instead, he created a structure that celebrated the very forest it occupied. The building doesn't dominate the landscape, it participates in it. This represents a completely new approach to mountain architecture. European mountain buildings were about protection from nature. Early American mountain cabins were about survival in nature. But these great camps and mountain hotels, they were about harmony with nature. The architects and builders of this period developed techniques that maximized the natural beauty of materials while achieving unprecedented scale and complexity. They created joinery systems that showcased the grain and character of individual logs. They designed structures that framed mountain views like living paintings. And they did it all using hand tools and human labor. Think about the skill level this required. Modern builders use computerized sawmills that can cut joints to tolerances measured in thousandths of inches. These 19th century craftsmen achieved similar precision using handsaws and chisels. They developed marking systems that allowed complex timber frames to be cut in multiple locations and assembled perfectly on site. They created lifting techniques that moved multi-ton logs into position, using nothing but ropes, pulleys, and human muscle. They pioneered foundation methods that worked with irregular mountain terrain while providing the level platforms required for precise timber framing. They solved drainage problems that would challenge modern engineers, using nothing but gravity and carefully calculated stone placement. But perhaps most impressively, they created maintenance systems that kept these massive structures functional through decades of mountain weather. Mountain conditions are brutal on buildings. Temperature swings that make materials expand and contract. snow loads that can crush inadequately designed roofs, winds that find every structural weakness and exploit it ruthlessly. These builders created structures that not only survived these conditions but thrived in them. Buildings that got stronger with age as timbers seasoned and joints tightened. Roofing systems that shed snow efficiently while maintaining structural integrity. Heating systems that worked reliably through the harshest winters, and they did it at a scale that still seems impossible today. The Great Camp era represented the absolute peak of traditional mountain building techniques. Every innovation developed by centuries of mountain builders, European joinery, Cherokee thermal management, mountain man adaptability, Mormon community organization, Ainai, was refined, perfected, and pushed to its absolute limits. These weren't just buildings. They were cathedrals of human ambition, monuments to what could be achieved when unlimited resources met unlimited skill and unlimited determination. But here's the thing about peaks. Once you reach them, there's only one direction to go. The golden age of mountain architecture was about to face challenges that would test everything these builders had accomplished. Economic forces were gathering that would make handcrafted luxury seem impossibly expensive. Industrial techniques were developing that would make traditional methods seem hopelessly inefficient. The railroad that had made these mountain palaces possible was about to bring something else to the mountains. Mass production, standardization, industrial efficiency that would transform mountain building from an art form into an assembly process. The age of the great camps was ending. The age of industrial mountain development was about to begin, and with it would come both unprecedented opportunity and the potential destruction of everything traditional mountain builders had achieved. The late 1800s transformed isolated mountain cabins into components of vast economic empires. And when I say vast, I'm talking about operations that moved more earth than the building of the pyramids, extracted more wealth than conquered kingdoms, and created boomtowns that appeared and disappeared like mirages in the desert. Except these mirages were real, and they were built to survive conditions that would destroy anything less than perfectly engineered. Mining operations in Colorado's Rockies demanded worker housing that could withstand altitude, weather, and the constant threat of avalanche. Towns like Leadville and Cripple Creek sprouted overnight, their buildings engineered for survival in what miners called the frozen hell. Now, think about the challenge these builders faced. You're constructing housing for thousands of workers at altitudes where the air is thin enough to make simple exertion exhausting, where winter temperatures drop to 40 below zero, where avalanches can bury entire neighborhoods without warning, and you need to do it fast, because the gold won't wait, the silver won't wait. Every day of delay costs thousands of dollars in lost production. The completion of the Denver and Rio Grande Railroad in 1883 brought civilization to previously unreachable peaks. But here's what really gets me excited about this moment. It wasn't just about transportation. It was about completely revolutionizing the logistics of mountain construction. Entire prefabricated buildings traveled by rail, then pack mule, to mining camps above timberline. Think about that supply chain for a second. A building is manufactured in Denver, loaded onto a train, carried to the end of the rail line, transferred to pack animals, carried up mountain trails that would challenge experienced hikers, then assembled at locations where a single mistake could trigger an avalanche that would bury the entire operation. The town of Alma, Colorado, built at 10,360 feet, required every piece of lumber to be hauled up treacherous mountain roads. Every nail, every pane of glass, every shingle. Materials that weighed thousands of tons, transported by teams of horses and mules working in conditions that would kill them if they weren't properly managed. But here's where the story gets really interesting, because the same railroad technology that enabled this construction boom also created the largest industrial operations in human history. Railroad logging operations created the first industrial-scale mountain construction. Camps housing thousands of workers appeared in the forests of Washington, Oregon, and Northern California. The Bloedel Donovan Lumber Company's camp near Mount Baker employed 1,200 men in a town that could be dismantled and moved in 60 days when local timber was exhausted. 60 days. Think about that. A town of 1,200 people, complete with housing, dining facilities, workshops, and infrastructure, designed to be packed up and relocated like a traveling circus. This wasn't just construction, it was construction logistics raised to an art form. Every building had to be designed for rapid assembly and disassembly. Every component had to be standardized so it could be reused in different configurations. Every system had to work efficiently regardless of local terrain conditions. But mountain construction faced a threat that no amount of engineering could completely solve. Fire. The Great Hinckley Fire of 1894 destroyed 6 towns and killed over 400 people, demonstrating that mountain buildings needed fire-resistant design that went far beyond anything previously attempted. Here's what made this fire so devastating. It wasn't just a forest fire. It was a firestorm that created its own weather patterns. Winds of over 100 miles per hour, temperatures hot enough to melt metal, flames that jumped rivers and roads like they didn't exist. Buildings that had survived decades of mountain weather were consumed in minutes. Entire towns disappeared so completely that rescue workers couldn't find their foundations. This changed mountain construction forever. Builders began using metal roofing, stone foundations, and defensive spacing that treated wildfire like an enemy army. They developed evacuation routes and emergency procedures that assumed total building loss was possible. But they also began designing structures that could survive fires that would destroy conventional buildings. Stone and earth construction that could withstand direct flame contact. Underground storage that protected essential supplies. Roofing systems that wouldn't ignite even when exposed to flying embers. And then something unexpected happened. Military experience began influencing mountain construction in ways that would transform the entire industry. The Spanish-American War brought military engineers to mountain construction. Army camps in the Philippines taught builders about tropical mountain conditions, while fighting in Cuba demonstrated the value of elevated construction and cross-ventilation. Now, you might think tropical mountains don't have much in common with Rocky Mountain peaks. But here's the thing. Both environments demand buildings that can handle extreme weather swings. Both require construction techniques that work with limited local materials. And both punish builders who don't understand local conditions. Military engineers brought systematic approaches to problems that civilian builders had solved through trial and error. They introduced standardized testing procedures, documented construction techniques, and quality control measures that ensured consistent results. These lessons transformed mountain cabin design when veterans returned to build homes in the American West. Buildings began incorporating military innovations in ventilation, drainage, and structural reinforcement that made them more durable and more comfortable. But the real transformation came from understanding buildings as systems, rather than individual structures. Military engineers think about logistics, supply lines, maintenance, and operational requirements. They design buildings to support specific missions under predictable conditions. They plan for equipment replacement, personnel changes, and operational modifications. Civilian mountain builders began adopting these approaches. Instead of building individual cabins, they began planning mountain communities with shared infrastructure, coordinated maintenance, and standardized components that could be repaired or replaced efficiently. This represented a fundamental shift in mountain architecture philosophy. Traditional mountain building was about creating individual solutions to local problems. This new approach was about creating systematic solutions that could be applied across multiple locations and modified as conditions changed. Railroad technology enabled this systematization. Standardized materials could be manufactured in distant locations and shipped to multiple mountain sites. construction techniques could be developed in one location and applied in dozens of others. Quality control could be maintained across vast geographic areas, but systematization came with costs. Traditional mountain building techniques had been refined over centuries to work with local materials and local conditions. Standardized approaches often ignored local advantages in favor of universal solutions. Buildings that would have been perfectly adapted to specific mountain microclimates were replaced by structures that worked adequately in all conditions but excelled in none. Local materials that had proven their worth over decades were abandoned in favor of shipped materials that met standardized specifications. The age of industrial mountain development was reaching its peak. Construction techniques that could build entire towns in months were creating unprecedented opportunities for mountain resource extraction and development. But these same techniques were beginning to eliminate the accumulated wisdom that had made traditional mountain architecture so perfectly adapted to local conditions. The knowledge that had been passed down through generations of mountain builders was being replaced by standardized procedures that worked everywhere and nowhere. The stage was set for the next great transformation in mountain building. Industrial efficiency was about to meet economic reality in ways that would challenge every assumption about mountain construction. The boom times were ending. Economic forces were gathering that would test whether industrial mountain building techniques could survive in conditions where efficiency mattered more than scale, where local adaptation was more important than standardization. The golden age of mountain development was about to face its greatest challenge, and that challenge would determine whether traditional mountain building wisdom would survive or disappear forever. The 1920s brought the first serious challenge to traditional mountain building wisdom, and when I say serious, I mean existential. Mass production and modern materials stormed the mountains like an industrial army, threatening to destroy techniques that had been perfected over centuries. Steel framing promised faster construction. Concrete offered fire resistance that wood could never match. Prefabricated components meant buildings could be assembled by workers who didn't need years of specialized training. And here's the thing that really gets me about this period. The new techniques worked. They worked really well. Buildings went up faster than ever before. Costs dropped dramatically. Construction that had required master craftsmen could be completed by general laborers, but something was being lost in the process. Something that took centuries to understand its value. The Great Depression accelerated this transformation in ways that still shape mountain construction today. The BRECUs, Civilian Conservation Corps, employed thousands of men to build standardized structures using government specifications that completely ignored local traditions. Think about what this means. You have experienced mountain builders, men who understood local weather patterns, local materials, local construction challenges, and you're telling them to build according to specifications developed in Washington, D.C., by bureaucrats who have never seen a mountain, let alone built on one. CCC camps across the American West erected identical buildings, whether they stood in Arizona desert or Montana snow. The same foundation details, the same wall systems, the same roofing techniques. Efficiency trumped adaptation as federal budgets demanded lowest cost solutions. And you know what? It worked. Kind of. These buildings served their purpose. They housed workers, provided meeting spaces, stored equipment. They did what they were designed to do, but they didn't do what traditional mountain buildings had always done. They didn't participate in their environment. They didn't adapt to local conditions. They didn't improve with age, as builders refined techniques based on local experience. They were industrial products dropped into mountain environments. And like all industrial products, they worked adequately until they didn't. World War II delivered what felt like the killing blow to traditional mountain crafts. The military's demand for lumber stripped mountain forests. Rationing made traditional materials unavailable. Every piece of quality timber, every pound of metal hardware, every skilled craftsman was needed for the war effort. Prefabricated housing, developed for military bases, offered quick solutions for post-war housing shortages. These buildings could be manufactured in factories, shipped to remote locations, and assembled in days rather than months. Veterans returning to mountain areas often chose mass-produced cabins over custom construction, not because they preferred them, but because they were available, because they were affordable, because traditional builders were either gone or too expensive for families starting over after the war. The economic logic was undeniable. Why spend months handcrafting joints when machine-cut components fit together perfectly? Why use local materials that required special handling when standardized materials came with guarantees and technical support? Plastic and aluminum siding replaced log walls. Fiberglass insulation made thick timber construction seem wasteful. Building codes, standardized for urban conditions, required mountain builders to use materials and techniques that ignored altitude, weather, and local resources. Insurance companies refused coverage for traditional construction, forcing compliance with standardized methods that insurance adjusters could evaluate using standard criteria. And here's where the story gets really frustrating. These standardized methods often performed worse in mountain conditions than traditional techniques they replaced. But they were easier to specify, easier to inspect, easier to repair using standardized parts and procedures. The system was optimizing for bureaucratic efficiency rather than building performance, and traditional mountain builders found themselves pushed to the margins of their own industry. But in remote areas, a few master builders continued the old ways, and their stories give me hope that traditional knowledge wasn't completely lost. Finnish immigrant Reino Kangas built over 200 log structures in Minnesota's North Woods, each one demonstrating that traditional techniques could surpass modern construction in durability and efficiency. His buildings, constructed entirely without power tools, still stand while concrete structures from the same era crumble. Reino understood something that industrial builders had forgotten. Buildings aren't just shelters. They're relationships between humans and their effective and environment. Good buildings get better with age, as materials season, joints tighten, and thermal properties stabilize. Industrial buildings are designed to meet specifications at the moment of completion. Traditional buildings are designed to improve over decades as they adapt to their specific environmental conditions. Reino's buildings were constructed using techniques that hadn't changed substantially since the Middle Ages. Hand-selected timbers, hand-cut joints, chinking materials gathered from local sources, foundation stones placed according to principles that prioritized longevity over construction speed, and they worked better than anything modern technology could produce. Better insulation, better structural integrity, better harmony with local weather patterns, better resistance to the kinds of long-term stresses that destroy industrial buildings. But Reino was working against economic forces that made traditional construction seem impossible. Labor costs were rising, skilled craftsmen were disappearing, clients expected buildings to be completed in weeks rather than seasons. The knowledge that had been passed down through generations of mountain builders was disappearing faster than it could be documented. Techniques that had been refined over centuries were being abandoned in favor of methods that were easier to teach but less effective in practice. By the 1960s, traditional mountain building seemed to be dying. The few remaining master craftsmen were aging out without finding apprentices. Young builders were learning industrial techniques that worked adequately, but lacked the depth and adaptability of traditional methods. Building supply networks were optimized for standardized materials. Local sawmills that had provided custom timber for centuries were closing, as lumber companies concentrated production in large facilities that served regional rather than local markets. Even the knowledge infrastructure was disappearing. Traditional building techniques had been passed down through apprenticeships rather than formal education. When the apprenticeship system collapsed, the knowledge went with it. Architecture schools taught industrial construction methods. Building codes specified standardized materials and techniques. Professional licensing required knowledge of modern systems rather than traditional crafts. The entire institutional framework that had supported traditional mountain building for centuries was being replaced by systems that prioritized efficiency, standardization, and legal compliance over building performance and environmental adaptation. And yet, something was stirring. Environmental consciousness was beginning to question the assumptions that had driven industrialization. Energy crises were making people reconsider the efficiency of buildings that required constant heating and cooling to remain comfortable. A new generation of builders was beginning to study traditional techniques, not as historical curiosities but as potential solutions to contemporary problems. Young people were discovering that buildings constructed by previous generations often outperformed modern structures in energy efficiency, durability, and occupant comfort. The stage was set for an unexpected resurrection. Traditional mountain building wisdom was about to be rediscovered by a generation that combined respect for traditional knowledge with modern understanding of building science. The Renaissance was coming, and it would transform mountain construction in ways that honored both ancient wisdom and contemporary innovation. The 1970s witnessed something that seemed impossible just a decade earlier, an unexpected resurrection of mountain building wisdom that had been written off as obsolete, primitive, outdated. Environmental consciousness and energy crises made people reconsider the efficiency of traditional techniques, and what they discovered changed everything. Young builders, studying with surviving masters, discovered that log construction offered superior insulation, durability, and environmental harmony compared to industrial alternatives. Not just adequate performance, bleu, superior performance. Think about this revelation for a moment. The techniques that had been abandoned as inefficient were actually more efficient than the industrial methods that replaced them. The buildings that had been dismissed as primitive were actually more sophisticated than modern structures. This wasn't nostalgia, this was hard science. Thermal imaging revealed that traditional log construction created more stable interior temperatures with less energy input. Structural analysis showed that hand-cut joinery often exceeded the strength of machine-cut connections. Environmental studies demonstrated that traditional buildings had lower lifetime environmental impacts than industrial alternatives. The Back to the Land movement brought thousands of urban refugees to mountain areas, creating demand for authentic mountain homes that worked with natural systems rather than fighting them. Books like The Owner-Built Home by Ken Kern taught building techniques that combined traditional wisdom with modern understanding of physics and materials science. These weren't historical reproductions, they were evolutionary improvements that honored traditional principles while incorporating contemporary knowledge. Communities like Drop City in Colorado experimented with geodesic domes adapted for mountain conditions. These builders were asking fundamental questions about the relationship between humans and their built environment. Questions that traditional mountain builders had been answering for centuries. But here's what really excites me about this period. Modern tools revolutionized traditional techniques without abandoning their principles. Chainsaws and portable sawmills made on-site timber processing economical again. Builders could select trees from local forests, mill them according to specific requirements, and incorporate them into buildings while the wood was still adapting to local moisture conditions. Improved understanding of wood science led to better preservation and joinery methods. Traditional techniques that had worked through trial and error could now be explained and improved using scientific analysis of wood properties, moisture dynamics, and structural behavior. The Scandinavian technique of scribing logs with power tools created joints more precise than hand methods, while maintaining traditional appearance and performance characteristics. This represented the perfect fusion of traditional wisdom and contemporary capability. But the real transformation came when green building standards emerged that favored mountain building traditions over industrial methods. Passive solar design, superinsulation, and thermal mass techniques echoed principles that mountain builders had used for centuries. The Leadership in Energy and Environmental Design program awarded points for local materials and traditional techniques that previous building codes had discouraged. Suddenly, traditional mountain building wasn't primitive, it was cutting-edge environmental technology. Buildings that worked with natural heating and cooling cycles rather than fighting them. Structures that used local materials and reduced transportation impacts. Construction techniques that created buildings designed to improve with age rather than deteriorate. Today's mountain builders represent a new breed of craftsman scientists. They study building physics and structural engineering while maintaining deep respect for traditional wisdom. Computer modeling allows them to test traditional designs against modern performance standards. And you know what they're discovering? Ancient techniques often achieved results that contemporary methods struggle to match. Traditional log construction creates thermal mass that moderates interior temperatures more effectively than modern insulation systems. Hand-cut joinery distributes structural loads more evenly than machine-cut connections. Local materials often provide better long-term performance than shipped alternatives. But modern mountain builders aren't just copying traditional techniques. They're improving them using contemporary knowledge and tools. Advanced moisture meters allow precise control of timber moisture content for optimal joinery. Thermal imaging identifies performance problems that traditional builders had to detect through experience. Structural analysis software enables complex designs that honor traditional principles while achieving unprecedented scale and efficiency. The marriage of traditional wisdom and modern knowledge is creating buildings that would amaze both ancient craftsmen and contemporary engineers. Solar panels integrated into traditional roof designs, radiant floor heating that works with massive timber construction, insulation systems that combine modern materials with traditional thermal mass principles. These buildings demonstrate that the future of mountain construction lies not in choosing between old and new techniques, but in combining the best of both approaches. Climate change demands buildings that can adapt to extreme weather while minimizing environmental impact. Traditional mountain building techniques, refined by centuries of experience and enhanced by modern understanding, offer solutions that neither pure tradition nor pure innovation could achieve alone. Modern mountain builders are creating structures that respond to environmental conditions the way traditional buildings did, but with performance capabilities that exceed anything previously possible. Buildings that generate more energy than they consume, while maintaining the warmth and character of traditional mountain architecture. Structures that use local materials and traditional techniques while meeting contemporary performance standards for energy efficiency and structural safety. The Renaissance isn't just about preserving traditional knowledge, it's about evolving it, about taking techniques that worked in simpler times and adapting them to meet contemporary challenges. And those challenges are significant. Mountain environments are becoming more extreme as climate patterns shift. Weather events that were rare are becoming common. Temperature swings that stress traditional buildings are becoming normal. But the principles that guided traditional mountain builders, working with natural forces rather than fighting them, using local materials and local knowledge, designing for adaptation rather than resistance, these principles are more relevant today than ever before. The future belongs to builders who understand both the accumulated wisdom of centuries and the possibilities offered by contemporary technology, who can create buildings that honor the best of mountain building tradition while meeting the challenges of an uncertain future. The story of mountain cabin design isn't ending, it's entering its most exciting chapter. A chapter where ancient wisdom meets modern innovation to create buildings that work better, last longer, and do less harm to the environments that sustain them. The mountains are still teaching. The question is whether we're still willing to learn. And based on what I'm seeing from today's mountain builders, the answer is a resounding yes. They're not just building cabins, they're building the future of human habitation in mountain environments. A future that honors the past while embracing the possibilities of tomorrow. a future where the genius of mountain cabin design continues to evolve, adapt, and inspire. The story continues, and I can't wait to see what comes next.